So when you have a known proportion, probability, percent, what calculator feature do you use that you learned about last night?
Hold on, I got it.
Normal PDF.
Norm CDF. Good job.
Plus
When you have, oh wait, hold on. No. This is unknown. When you have a known 3 P's, what are you going to use? Good job. Okay. The reason why I had to bring it for it is because I forgot to remind you. Kara, Samantha, Alexis, Sophie, you guys had conflicts when I tried to put you in for advisement on Friday. Okay, so just heads up. You can do whatever you want. No, I don't hold it against you, but you are going to have to know how to do 4A. Okay? Okay. All right, so with this in mind, right, let's look at these over here, okay? The first box, it says, suppose X follows a normal distribution, and then do you guys remember what it looks like when you have these two things? What's this and what's this? This is the mean, and this is the squared. This is the variance, right? So you're going to have to take the square root of whatever the second number is to get the standard deviation, okay? Hello. So then, at what value of X, so it's asking you for a boundary, is 73% of the data to the right? Ooh, that's a known percent probability, whatever. What are you going to use, inverse norm or norm CDF? Inverse norm. Okay, what about the second one? IQ scores are normally distributed, are approximately normally distributed, with a mean of 100 and a standard deviation of 15. What percentage of people have IQ scores greater than 115? What do you guys think for that one? Normal CDF, what teed you off? What clued you in? They want the percentage, right? What percentage means, hey, I don't know the percentage. Can you tell me? Norm CDF. Great. Third, IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 15. What percentage of people have IQ scores between 80 and 107? What do you guys say? What percentage? Normal CDF. Good job. Suppose X follows a normal distribution where the mean is 25 and the standard deviation is 5. Ooh. Between what values of X do 68% of the values lie? Ooh, that sounds like a known proportion percentage to me. What are we going to use? Inverse norm. Good job. We're looking for a boundary. We have a known percentage. IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 15. What percentage of people have IQ scores less than 110? Nathan, what do you think? Oh, sorry, I didn't see you there. I'm working ahead. It's okay, somebody help Nathan out. What'd you get? What'd you get? Norm CDF. Norm CDF. He's a good guy. All right, IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 15. Mensa, the largest and oldest high IQ society, is open to people who score at the 98th percentile or higher. What is the minimum IQ score to be accepted? So envision this thing, right? You've got a curve. You've got the 98th percentile. We are looking for the proportion that's 2%, the top 2% of the population, right? So what are you going to know? We have the proportion on the left, we have the proportion on the right. Both of those are known. What are we going to use in this case? It's asking for a boundary. We have known inverse norm. Good job. Below, suppose X has a normal distribution with a mean of 25 and a standard deviation of 5. At what value of X is 23% of the data to the left? Inverse norm. Good job. Assume the random variable X is normally distributed with a mean of 55 and a standard deviation of 8. Find the 5th percentile.
still inverse norm?
It is because you would know the 95%. Good job. Find the value of z sub a. That means the z-score that corresponds to the curve where 24% of the data is left with a. Z-scores are always inverse norm. Okay, we always use inverse norm to figure out z-scores. Good job. Okay. So that was a review of the videos. I have high hopes that you remember some of this from last year. Do you guys feel good about this topic from last year? Does anybody in this room feel good about this topic from last year?
Like the difference between inverse and norm?
No, just z-scores, normal distributions, stuff like that.
We don't really think about this because
Oh, really? Oh, do you guys need like the full run? I'll give you the full rundown. Here we go. Okay. So, take a look at this beautiful adult bell curve. Hang on. Look at him. I'm going to show him to you, okay? This is him. He's called the standard normal distribution curve, okay? He has a mean of 0, and he has a standard deviation of 1. He's called the standard normal distribution curve. He is the normal distribution curve from which all others come. Now, just like your parents, do you look exactly like your parents? Now y'all look a little bit different, right? Because y'all got different means and y'all got different standard deviations if you were bell curves, right? So, think about what that would look like for, that's not a good one. Let's do one that's like this, and he was 0, he has a mean of, alright, how does this guy compare to this guy? He has a different standard deviation, right? So he's gonna look a little taller, a little skinnier. How does this guy look? He's a little more spread out, he's a little flatter, so he's gonna possibly have a different mean and a different standard deviation. This guy has a way different mean. He has just been shifted to the right 50 units, okay? So let's think about this as the mother, the father, the one from which all normal distributions come. Did you know that that has an equation? I think we covered this in the video real quick. I taught you about this, right? You don't, yeah, you don't need to know this. You don't need to know this, but I feel like it's the only way that you understand it, right? So just check it out and watch real quick while I do this, okay? I'm gonna go back to the equation. Here it is. And I'm gonna type it into my calculator. And I think you should do the same. So let's go to a graph page. And we're gonna type in, it's on page, oh, there's a big arrow in front of it. 117, I think. And it says under hot take, there's an equation. Oh, I think I can scroll up to it actually. Right here. Okay, boom. Okay. So I'm typing this in right now. So I know that I'm working with the standard normal distribution right now. So what am I going to put in where the standard deviation was? This is going to be a 1 when I type it in. And then this is going to be a 1. And then this is going to be a 0. Okay? So now I've got 1. I'm doing this in my CAS model because they don't let you guys do infinite integrals in yours. And I knew I was going to have to do one, so I'm using my CAS. Okay. So what does this guy look like? He looks like a little mini baby bell curve, right? But he's so ever so tiny because the scale is weird. So let's change this to like a negative 0.5 and change this to like a 1. Oh my gosh, look at him. Yes. Okay. Mean of 0, standard deviation of 1. Okay, cool. Do you guys remember what?
Oh, you changed the.
I changed the scales, yeah. Okay, so notice that this equation is stored in F1. So that's his var, right? So follow what I'm about to do here, okay? I don't think you can do this in your calculator, so just watch. This is an integral function. An integral function calculates the area under a curve from one boundary to another. Now, what do we know about the standard normal distribution curve? We know that he goes all the way in the left direction till negative infinity, right? So we're going to put that as our lower boundary in the integral, okay?
Is that just like the 9? Oh, never mind.
Right, that's like bootleg in infinity. That's what we have to work with in the Inspire. But this is the real deal, so I wanted to show you in my CAS. Yeah.
You don't? Yeah, we have one.
You do, but it like if you put it in, it gets it like I don't know. You could try it. Tell me what it says when you put it in, because I don't know what the error is, but I remember doing it and it didn't work. So now I'm going to go all the way up to infinity, because in the right direction this tail goes on forever, right? And then I'm going to find the area under the curve that stored this guy, and I'm going to integrate with respect to x. Dang, what is this telling me? I know you don't know what an integral is, but use your brain, right? Under that curve, what is the total area under this curve? Then move your seat. You have to be able to see. You can't sit through math and you can't see. Just sit right there. So the area under the curve is 1. That means in either direction, if we added up all the areas scanning from left to right, it totals 1, right? And we know that because in a probability distribution, this is a continuous probability distribution. Yesterday we learned about binomial probability distribution. In a continuous probability distribution, the area under the curve always adds up to 1. Yeah.
I kind of off topic what you said.
Yeah.
What's the difference between like a binomial and a continuous?
So binomial is like discrete counts. So you're like, how many 4s? Because it has like a fixed number of trials, right? So it's like, how many 4s are you going to roll if you roll a dice 10 times, right? Those are like discrete counts. I'm like, I'm going to roll 3 4s. I'm going to roll 8 4s. This is like, what's the probability of catching an eel that's between 40 and 50 centimeters long, right? That's continuous data that came from measuring the length of eels, which can go in a continuous realm, right? It'll always tell you that it follows a normal distribution, so you never have to guess.
Oh.
It'll be like X, it'll either use the notation X, squiggly, and then it'll give you the parameters of the distribution, or it'll just say this follows a normal distribution. Okay? Good question. All right, so now that we see that, right, what if we shifted the mean or adjusted the standard deviation? What do you think is going to happen if I reintegrated the area under the curve? It'll still remain a 1. Why? Because every change in a standard deviation is considered a dilation of the curve, and every change in the mean is considered a horizontal shift. It's going to maintain that area no matter what, okay? So from the standard normal distribution curve, I can use the stuff that I know about that curve to answer questions about all of its children. You ever have a friend and then you meet their mom and you're like, oh. Or you meet their dad and you're like, oh. You know what I mean? We do the same thing with normal distribution curves, okay? So, for example, within one standard deviation of the mean, one standard deviation below the mean is considered to have a z-score of -1. A data point that is 2 standard deviations below the mean has a z-score of -2. A data point that is 3 standard deviations below the mean has a z-score of -3. So the z-score is kind of like saying the data point's absolute standing in regards to mean. Okay? And the reason why it works so well in the standard normal distribution curve is because the mean is 0 and the standard deviation is 1. So it's like nice counts. We can really wrap our head around everything. One standard deviation above the mean has a z-score of 1. 2 standard deviations, 3 standard deviations above the mean. Okay? Go back to the image from your homework last night. What percentage of the data lies within 1 standard deviation of the mean?
Wait,
34%.
Yeah, but like
68.
within both of them. Yeah, 68. Okay, so we got, that's sort of 1 from 1 to 1. There we go. Okay. All right. So we've got 68% right in here, or you can think about it like this. Okay. What about in 2 standard deviations of the mean? 95%, or we can think about it like that. And what about this guy? All right, cool. So, using all of that stuff, right, when we do a process called standardization, right, where we take the z-score, which is like the data points absolute standing in the standard normal distribution, and we convert it to our new stuff with new jazz, that is the corresponding value in the new normal distribution curve. That is a different mean. Okay. I know. We're gonna do some problems and it'll feel better, okay? Alright. So that's the stats theory behind it, right? But okay. Alright. I feel bad because I feel like set 7 gets all the tech glitches because I've like left the room and then my like internet has problems and then you guys get the full setup. Everything's fine by the time you guys get it. Alright, so I'm going to get out of CAS. While I'm doing this, just read the problem on page 119 and I'm going to fire up my calculator. Okay. Asia, do you want to move up there so you can see? Sure.
What are we doing in environment tomorrow?
We're introducing topic 4A, task 4A. It's pretty easy to follow along. Like if you got other stuff to do, it's not the end of the world one to miss. But everyone who doesn't have a conflict, I would recommend coming for sure.
So I should write my name under conflicts? Oh, she put that up there.
I put that up there because you were picked for 2 things, unless you were and I just didn't see. But
Oh, because I don't think I originally signed up. Can I like sign up now? I don't know.
we have like a spreadsheet and I just check off all the kids in my class, and if someone else already pulled you, it'll tell me.
So, okay.
So I guess no one pulled you then, yeah. But I also could have made a mistake, so I would double check if I were you.
Okay, because I got confused. I thought I put my name on like the board for this. I got confused.
Hey, do you know your eels? Jacob, do you know your eels? Do you know your eels?
What?
Do you know the difference between an electric or an acoustic eel? No, it's a joke. It's a joke. Please laugh. Please laugh at my joke. Look, he laughed. It's funny.
He's like, please stop.
He's like, don't talk to me. Okay. Eels are washed onto a beach after a storm. Their lengths, x, a continuous data value that comes from measurement, is normally distributed with a mean of 41 and a variance of 11. So what you should do right here is do mean is 41, standard deviation is the square root of 11. Okay. If an eel is randomly selected, find the probability that it is at least 50 centimeters long. You must draw the bell curve because it illustrates your thinking. And when you don't draw the bell curve, you get it wrong. Yes, you are special. No, you are not special enough to not draw the bell curve. Do you understand?
Yes.
Okay, perfect. So we're going to draw a bell curve because we are special, but not today. All right, so now, if an eel is randomly selected, find the probability that it is at least 50 centimeters long. So this is the mean. This is the standard deviation. And I'm going to put that 50, it looks like he goes above the mean because the mean's 41, right on my curve. And then I want it to be at least 50 centimeters long. So I'm going to do like a little bit of this, right? Is that not what we're looking for? Yeah.
Can you, like, do you always just shade what you're looking for? Because, like, last year, Carl told us, like, only to ever shade the tail. I know that's just, like, a way of simplifying it, or, like, does that make sense? Like, can you, could you have shaded either side of that thing, depending on what it asked you?
I'm getting in Krause's head. I believe he taught you, it's scary in there. No, I believe he taught you Z-scores, which
But with, like, a table.
scanned from the area from the left. So you had to do it, do you mean like you always had to shade from the left up?
No, you always have to shade the tail, like the shorter part, not the middle part.
Okay, I would
So
understand.
just scratch that though, is that what I'm asking?
I don't want to say it's wrong because he's like not wrong. I just don't know how you.
But
just
in
find
here,
that.
you can shade either sides.
Yeah, you're highlighting what you want to find.
Okay. That's what I'm
The
asking.
only way I'm thinking of like him doing it the other way is if he's like teaching you from the table, in which case it's always the area from the left because it's a cumulative density function if you're doing like normal CDF. But like
Okay.
other than that, I don't know why you would have like a specific spot that you always shade. Do you remember?
I know we use the table, but I don't remember.
Yeah. All right. I'm
Can
not
I
saying
talk
he's,
to you about though?
I'm
There's
not
something
saying he's
about the tail
wrong.
that he was
I'm just
like-
saying I don't know like.
But I'm saying in here, you doesn't matter.
In here, you're shading what you want,
Okay.
right? Okay.
That was my question.
Yeah.
Right.
So I want to find the area, right? Find the probability. That's going to be norm CDF. Find the probability that we have an eel that's from 50 to infinity, right? Because along the x-axis, that tail goes all the way on forever, with a mean of 41 and a standard deviation of the square root of 11. Okay? Yeah, and if you forget the order of the numbers, I always kind of just type it in my calculator first and then I write the numbers. But I just want to give you what to type in. Yeah, go to the calculator first. Do it in your calculator first and then you'll see. So you go menu 552. And then the lower bound, in this case, is 50. That's why I feel like in the diagram you want to shade what you want because it kind of tells you what to type in then, you know?
Oh, yeah.
Right. And then the upper bound, I think you have to type in fancy infinity because your calculator doesn't get it. Here, let's type in regular infinity and see what it says. I forget what the message is.
I did it with the other thing and it was like, it shut it down.
It just showed you a picture of a cheeseburger. Hold on, what is, yeah, see, it doesn't like it. Okay, so you have to type in bootleg infinity. Here's how you do it. You do menu 55. Oh, man. Okay, you go 9E99. That's like infinity, kind of. It's a really huge number. It's 9 times 10 to the 99. Close enough, right?
I like how it says, maybe try our other calculator.
It's like,
I
it's
don't
like
have
buy a
that.
Kaz, you poor, and you're like, what?
Where does it say that?
Excuse me?
It tells me, it's like, you can't do this, you need Oh, I don't just have one next to me.
What? Hold on, something went in wrong. Oh, I put a decimal in there. Dang, I didn't mean to do that.
Wait, is it square root of 11?
Yeah, and you have the square root.
Yes! Oh my gosh, 2 mistakes for the win. Okay, that's the answer. So, how did I know I was wrong? Because I got basically 0, fancy 0, and that's not what I was trying to get. So, I got 0.003327. Okay. So, the probability that an eel is greater don't sweat over the inequality symbol here because you're talking about a boundary and when you type it in you have to include it anyway. This is not getting graded. Like your notation is not getting graded, but it's a good mathematical practice because it helps you organize what you're going to use in further working. Does that make sense? So like you don't have to write it like this, but you should because it's going to organize your brain. So this is greater than or equal to 50. I just kept writing greater than in the last class and they kept yelling at me, so we're going to include it today. How about that? And that's 0.00, and then this would be just a 3. Okay.
Is that considered 360?
Yeah, you got 1, 2, 3.
Oh, I thought this
Okay. Like after the 3 they want it.
Wait, what? There's 2 zeros after.
Yeah. Also, it's just 1 point on the test, so don't worry about it.
What'd you say?
It's
Oh,
1 point on the
yeah.
whole exam. But do your best, but also don't worry about it. Find the proportion of eels measuring between 40 centimeters and 50 centimeters long. Ooh, let's do it again. I've got a mean of 41. I've got a standard deviation of the square root of 11, and I'm from 40 to 50. Okay, so this is kind of close to the mean. Oh, that should be a 40.
So just shade that middle part.
Yup. And then this should be a 50. So the proportion or area under the curve that I'm looking for is this number right here. If I'm finding a proportion, I'm using norm CDF, right?
Yes.
These also kind of, once you understand the concept, these also kind of become plug and chug, if you will.
Yes.
Yes. A callback. All right. Get out of here. Get out of here. Okay. All right. 0.61515. Oh, he's a sandwich. I gotta open up the sandwich. 40's on the 40 and 50 are the bread. Okay.
It includes 40 and 50.
Oh my god, this thing won't even let me change highlighter colors. Forget it. You get no colors. You get nothing cute. This thing is cooked. I can't do it. I can't do it. Okay. How many eels? Ooh, okay. How many eels in a sample of 200?
Inverse.
We are kind of I love how you thought that was good. But think about it like this, right?
Was that wrong?
Yeah.
Oh, okay.
So you got a basket of like 200 eels swimming around, right? In those 200 eels, if you know the probability that it's at least 45 centimeters in length, you're trying to find how many expected eels would be in here, right? Wouldn't you? Yeah. You would do E of x is equal to n times b.
She really said, aw. She said, aw, that's cute.
No, I didn't. You all know that my brain is a bowl full of mayonnaise. It's fine. All right, so we've got sample of 200. What is that, my N or my P?
Your N.
Okay. What's my P?
You have to find it.
E. I gotta find it. What's my mean? 41. What's my standard deviation? Square root of 11. Then I got 45 is greater than this guy. So now we're gonna just do the thing. Wait, redemption. What am I using?
He's scared.
Don't be scared.
It's norm now.
Yeah.
He's so scared. Like,
See, I thought of like finding an X value, so I was like, oh,
Don't ever be scared.
terrifying.
Have the confidence of my daughter. Last night she like got in a literal fight with my husband because tornadoes and thunderstorms were the same thing. She's like, you don't understand that they're the same thing. It's like, all right, girl, tell him.
we had
Was it
tornadoes
even
that
thundering last night?
No, she's just like, she's terrified of tornadoes. I'm like, you live nowhere near where a tornado would
I
happen.
used to be terrified. of
Really? Huh.
Because I didn't just feel like
Didn't we used to have, didn't we have a tornado here like 25 years ago?
Oh
Yeah.
my God, don't ever tell her that.
tornadoes.
They are like a thing to be, I understand why they would be
I feel
terrifying.
like hurricanes are more scary.
When I was really little,
No.
my mom sent me like this like video from a movie of like people getting sucked into a tornado. And she like told me like, like if that ever happens, like I need to run as fast as I can and drive away as fast as I can because I'm not like basically like I'm not coming. Basically, I'm cooked.
Liana, you will not make it out of this.
Basically, is what she said. I don't know why she's. What's wrong? I don't know why she like wanted to scare me so bad, but yeah, that's my little trauma.
Oh my god. I used to always get like have nightmares about plane crashes. I don't know why those freaked me
That's
out.
what I love here though, like,
Now I like get on a plane and I just like immediately fall asleep and I don't care at all. Wait, let's think. Okay, I just typed this in. I put in my 200 trials. I put in my probability that I found with norm CDF. How many eels did I get?
22 point, wait. No.
Yeah, 22.8. Wait, hold on. Jacob, he knows eels. What is it? How many eels is
why do you
this?
think that-
22.8. I don't know. I just like to mess with him because he's right there. How many eels is this? If we have 22.8, can you have 22.8 eels? What should we do?
Good, but that wouldn't be a lot.
We should round it up to 23, right? It's about 23 eels. It's around 23 eels, right?
I remember last year when we were shrinker, we always had this like discussion with her. It was one of the
Oh my gosh, yes.
of us
About
saying
eels?
You
No.
can't.
Was Jacob there? No.
You can't generate a new person
Yes, you have
if
to
you
round
have
down.
half a
I
person.
thought like
so
a
you
living
round
thing you
down.
always had to round
Yes,
down.
I thought
Like,
that
you
too.
can't have half. Like if
Because
you're
not at a
are a
full
little different. Like a
28
person,
eels.
if you have a question about a person, your answer is 22.8 people. They had to round down to 22 because you can't just make
No,
them a
I
person.
thought that too. Because it's like.
That makes sense,
Because
but
you're
like,
not at 23
If a shrinker
yet.
was like, no.
Yeah,
They were like,
that's
okay.
exactly how she said it actually.
She's like, no.
I think it's case by case because like if you're talking about a basket of eels, it's like, hey, Bob, how many eels are going to be less than 45 centimeters? And he's like, I don't know. I calculated it's about 22.8. I'm going to say about 23. Would you be like, Bob, you're wrong? No, you'd be like, it's probably like around 23, Bob. Sure.
But, like,
Bob.
yeah, I guess
Sure,
it depends on
Bob.
the context of the problem. But, like,
Yeah, I don't know.
We always had this discussion. And it was,
Racks
like,
You know
so
what you
easy.
do always have to round down for though? Those problems where it's like, how many cans of paint is it going to take to like cover
the
this? You'd have to
geometry
round
questions?
up because you got to make sure you have enough paint. So I guess it
The
depends on
geometry
like,
questions,
I
yeah.
feel like it's like an elementary thing. It's like you can't have half a person. Like that's what they tell you.
Which is such a problematic like opening because then the kids are always like, what are those people? And you're like, oh my God, stop. No. Oh my God. I hate answering those.
Or, like,
Okay.
They always told you you need to have like labels, which like you do in like units, but like not as much as like they stress in elementary.
23
You're like, what if it's
elephants.
25? Snake?
Instead of 25. Okay, you know what's
That's a new fear unlocked, 25 snakes. Okay, the diameters of pistons manufactured by a company are normally distributed. Only those pistons whose diameters lie between 3.994 centimeters and 4.006 centimeters are acceptable. Oh, okay. Also, can I tell you that like every year there's a question just like this on the test, and every year kids are like, you never showed us how to do a problem like this. And I'm like, I literally spent like 10 minutes in class showing you how to do a problem like this. So there is a problem like this, and it's this one. So I'm covering my bases now. I showed you, okay? All right. So it says find the mean and the standard deviation of the distributions if 4% of the pistons are rejected as being too small and 5% are rejected as being too large. Okay, as soon as you see find the mean and the standard deviation, you write z-scores. You will be using z-scores to find an unknown mean or standard deviation. All that other stuff you can just use norm CDF or inverse norm. You just gotta figure it out, okay? All right. So now let's put our clues on here. I don't know what the mean is, but I'm gonna pretend. And I don't know what the standard deviation is, but I'm gonna pretend. Just because it's a habit. Now I'm gonna put the clues on there. I've got 3.9994, and then I got 4.006, right? And it says 4% of the pistons are rejected as being too small. So this is, stop it, 0.04. Yeah? This is what? 0.05. Good job. So, these are my two clues. Let's call this guy clue 1. Let's call this guy clue 2. All right. So using these two clues, I'm going to try to find my unknown mean and my unknown standard deviation. G, 2 clues, 2 unknowns. Okay, I'm just gonna leave that there. When I'm trying to find the mean and the standard deviation, I'm going to start with the z-score conversion. Okay? Now, remember, the z-score is the data's relative standing in the standard normal distribution curve. Okay? We can find the z-score by finding the inverse norm of that portion of the data and the area to the left of it in the standard normal distribution curve. Stop it. Watch. Okay, so I'm in here. Menu 553. Area is 0.04. Okay, so that's my z-score. Oh, I erased my standard normal distribution curve.
Oh, because the area is always going to be the same. Is that why?
Ooh.
What is the zero? Oh, zero is the.
So this guy, oh, what did I get? Negative 1.75. He's like here. So this is 0.04 of an area.
It's all clicking.
Okay.
Oh, it's all starting.
I know it's not great. You'll get there.
So it's starting.
All right, so that was equal to, what was the boundary that corresponded to that? We don't know, okay? So this ends up being negative 1.75068, and then is equal to 3.994 minus the mean over the standard deviation. Okay, we're gonna leave that there. Let's go to the clue 2. Clue 2. I am finding an unknown mean or standard deviation. This desk is just a little too small. It makes me drape over it like with strange body language, but okay.
Are we going to do 0.95 if we're reading from left to right? Wait.
Oh my god, yes! But I didn't get there yet. Okay, no, you're good. So I'm going to find the z, and the way I find the z is I do the corresponding area, but on the standard normal distribution curve, because that's what a z-score is. Okay, so now I'm going to do inverse norm. However, the z-score is reading from the left up to that boundary. So you need to find the area from the left up to where you are. Maybe this is what you were remembering from last year, perhaps. So you're going to have to do 1 minus 0.05 whenever you are given this guy to the right and you need the area to the left. Okay? And then, oh, this was the boundary that corresponded to that. Okay. Now, I have 2 equations with 2 unknowns. What do you think I should do?
Solve.
I've used my calculator for the whole problem up until now. So I do have it available to me. What do you think I should do?
And solve.
And solves for 1. We're almost there. Together we have it all. Lin solve. Boom. Okay. How does that sweet redemption taste? Okay, so now we're going to go to menu 3.2. And allow me to make a suggestion. When you're typing this stuff and it's hard to keep track of your things, so I changed the standard deviation to an S and I changed the mean to an M. Because then when it gets my answer, they're always like weird decimals. It's hard to remember which one I put in first. So I do S, M, excuse me. And when you're typing it in, it doesn't like if there is a variable in the denominator because there's going to be a value where he's undefined. So it's going to be like, this isn't a linear equation. What are you doing? Typing irrational functions, you clown. So what you have to do is you have to multiply this guy over here and you end up with like a linear thing that you can just type in. Does that make sense? So you have like this equals 3.994 minus mean. So it's basically like you just cross multiply so that way you don't have a denominator anymore.
Why doesn't it like that though?
Because then it thinks you're putting in a rational function and it's like, if the standard deviation was 0, then it would be undefined. What are you doing? You know, but if you like put it over there, somehow it doesn't get freaked out. So yeah, no, it would have the most annoying voice.
That's what I feel like though, like whenever it says error like that, feel like that's what it's saying.
It's like, what's wrong with you?
It's
It's like, buy the expensive version, you loser. And you're like, what?
the villain advertisement was crazy.
Wait, what did we get for our answer on the left? Oh, we never found the inverse norm. LOL. Somebody find it. What is it?
1.64485.
All right, there we go. We kind of skipped a few steps there. Is everyone okay with how we got
Yes.
this? Someone else answered besides Leon, so I know we're okay. Are you guys okay? Do you see how we got those two?
Yes.
Okay. So let's type them in, and instead of the sigma, we're going to put an S. Instead of the mu, we're going to put an M. Okay.
Yeah, how can we change the average symbol all of a sudden, just for this one unit?
Because
Our X bar has been it for like everything else,
And-
and then as soon as we get to statistics, it's
I know, because IB never, yeah, it doesn't make you distinguish between a population or a sample. And whenever you do normal distributions, like populations are always normally distributed because there's like a ton of data points and it's continuous data and it's about like human measurement and stuff. So like, I guess they are just overlooking the fact that they don't make you learn the difference between the two, and they're like, just use
So we can
me.
use mu for everything.
But they're like,
I mean, your one var stat spits out an X bar.
Everything in stats.
So.
No, but one of our stats.
One var stats, and they could be like, X bar is 8. Find if you add 4 to every data point, what happens to the mean?
Okay,
Like,
so everything except one
so
var stats.
just know that they both mean the same thing, and that they didn't want to teach you the difference between the two. So now they're just gonna give you both. I don't know. Very, very suspicious. 68068 S equals 3.994 minus M. Okie dokie. All right, so our mean.
How do you write like
Let-
divided and solve? Or then solve?
Just write it.
Oh yeah, you can just do like this. Len solve.
Oh.
You like clearly show the two equations that you landed at, and then you just do len solve. Oh my, 0, 0, 4, and then the standard deviation. What did I type in first? Oh, that's the standard deviation. See, that's why you got to write the thing so you don't lose which one was which. I hate this.
Why?
Like, what does that even round to? Come on, come on. Okay. All right, so next, down here, find the probability that the diameter, remember, you're using your stuff from the calculator, not those loser rounded versions up there that were annoying. Between 3.997 and 4.003. So now you have the mean. Sometimes you draw a curve and it looks good, and sometimes you draw a curve and it looks like this. This one looks like a hot dog in the wind. So we have this is a hot dog in the wind. All right. And then we are between 3.997 and 4.003. Okay. Come on. All right, so what are you going to type this one in as? Norm CDF.
Wait, are we still in A? 2A? Wait, are we actually?
No, we're on 2B, but these
So
dudes.
what's the answer to 2A?
Oh, it was whatever your calculator spit out. The
Oh.
mean and the standard
Oh,
deviation.
I see.
Wait, oh, I wrote it as an S. It's that.
Sorry, I'm
Okay.
behind. I actually don't feel like it's on the day right now, so I think it's like the middle of the day. Thank you.
That is a good feeling.
Yeah,
You guys are funny. Who is the pairing in this room that spends the most amount of time in classes together. Wouldn't that be interesting to figure out? Who do you think spends the most, who is in the most classes with one another in this room?
I gotta look at
They both looked at each other like immediately. What do you think? Oh, it's a sandwich. It has to lie between.
I have one person who I have like 5 to 6 classes. Yeah. Sam, I have second, third, fifth, sixth, seventh together.
the fact that she laughed. I would have laughed. But
I don't know who that is, but it's funny.
the only people I've passed with outside of class is one class.
Are we feeling a little better? Does anybody have any questions?
Yeah, you.
Eh. All right. Let's go to 3. Woo! The weights of Schlanpufas. Who knows what a Schlanpufa is? Yes. Yes. The weights of Schlanpufas are normally distributed. 84% of Schlanpufas weigh more than 152 grams. Oh my. Okay, so, oh, what an interesting curve it came out this time. Okay, more than 152. Okay, so 84% weighs more than 152, but then 16% weigh more than 200. This is a complicated diagram. Okay, so this has 0.16. This has 84 minus 0.16. So we would have 84 minus 16 would give me 68. So there's 68 in here. Whoa, hey. Anybody not sure what I did just there? Besides freeze my computer. You couldn't handle that? You couldn't handle me writing a 6? Okay, I see how it is. Fine. Fine.
Do you see this?
I do.
Who can work under these conditions? Okay, so then what's left over here then?
Where are we getting 68? Oh.
16.
I did 84 minus the 16 up here to find what the piece in the middle here was.
So on the left side, it's also 16.
Okay, so, all right, find the mean and standard deviation for the crop of shit. I didn't know what to call it, for the crop of corn food.
Sophie knows how to do.
Okay, so ordinarily, you would see mean and standard deviation and you would write what? Z-scores, right? When you have to find those. But in this one, they give you a sneaky snake clue that can help you save a lot of time. Who sees the sneaky snake clue? Anyone see the sneaky snake clue? Hallelujah. But it is a number. It is important. Who can tell me why it's important?
One standard deviation.
Ah!
You crushed that then?
Rock on said 8. Okay, this is within 1 standard deviation of the mean. If we are within 1 standard deviation of the mean, then I just do 200.
Hit send who from? Just the.
It's 60.
It's just like we were like putting the stuff on the diagram and then we were labeling stuff and then all of a sudden we were like, oh my god, the 68% of the data is right there. So now I just do 200 minus 152 and then divide it by 2 and hopefully land on the mean. Figure it out and tell me what it is, because then you'll be able to tell whether it's the mean or the standard deviation, right? Yeah. Which is the, why can't it be the mean?
That's
Is it
because
too
we
low?
152.
Right, way too low. So this is the standard deviation, okay? Anybody unsure how we worked through that? That was kind of a hack.
Wait,
You can also use Z-scores if you're like, what?
wait, so was it possible for the mean to result from that equation?
Absolutely, we can figure out the mean from that, right?
Because then you could just take 152 and add 24.
Exactly.
Oh,
So
but like
now, we have to find both yet.
But they're
So now I
divided
could
by
do
2.
152 plus 24, what would that end up being?
76.
Yep.
6 is what I said, actually. God.
He just wanted it to be 6, 7 so bad. Okay.
Wait,
So
hold on.
the reason why we were able to do this was because the given probability was 0.68 between these two data points, which are 1 standard deviation both above and below the mean. In the last problem, we had clues that were 4%, 5%, not helpful. Can't use that clue, okay? Or can't use that relationship of 68% of the data lies within 1 standard deviation of the mean, that jazz, okay? So this only works in certain cases, okay? Are you cool on that?
Yeah, no.
Yeah, okay.
Wait, could we have just done to find the mean 200 plus 152 over 2?
200 plus 152 over 2. Yeah, that could be, you could mean first and then you would do the standard deviation the other way, yeah. Okay, they used to be oranges, but those are boring, so I changed it to Schlampupas. What percentage of the Schlampupas weigh between 152 grams and 224 grams? I don't know, I'm gonna have to draw a new diagram, because that's what I always do. It's like Ken gave Barbie, wasn't it like a muffler or something like that?
A muffle, like.
She was like really excited about it. I think it was Raquel.
No, I
It
knew
was
you
like,
remember.
Oh,
but I
yes,
just don't
yes,
know what
yes.
it is exactly. I feel like I remember that before.
It's got a weird name.
It's gotta be like German.
That's what Raquel is.
Schlampupa.
Or it's gotta be like. I don't know.
How do you find this? What are you trying to do? Maybe my computer's done yelling at me now. What would you guys do? Norm CDF, good job. This is a plug and chug, if you will. Let me know what you get. Bless you. Whenever Kraus is teaching in my room and I sneeze, he goes, "Stop trying to get attention."
Oh, that's actually really good.
And it makes me laugh so hard every time.
Wait, when he's teaching, you just like sit in the back and do nothing.
What? No, I'm like fighting for my life doing so much work.
Yeah, but that's what I meant, like you're.
Yeah, I'm just like totally ignoring him, and then all of a
Wait, why does
sudden,
he teach in your room?
we just like randomly share a room for set 1, and then we teach together set 2.
But why?
Teach together?
Does he
Yeah.
have his own room? Why can't he teach his own in set 1?
Miss Ruccio's teaching in there.
Oh, okay. So he just doesn't have a home?
Kraus is in fact without a home.
And he's been
He's a
technically retired for
refugee.
2 years.
You don't have.
Not the downside to being fake retired. Faking your retired.
That's true. My dad has to work willingly at the shop from useful places. He's not allowed in
Yeah,
the
your
shop.
dad is never allowed to retire. Like, never will they ever find a tech teacher.
All the tech teachers are never allowed to retire. Like, they all come back at some point. They all come
Or they
back.
like go to a different building.
Do you think Randall's gonna stay? He retires
Oh,
this year.
yeah. Oh, they're going to find him. They're going to be like, sir,
'Cause
you're
he
not.
has a job at Optimat.
Really?
Yeah, that's
Oh
why
my
he does have to.
Nah, so human resources
Oh
gonna
my
find him.
God. They're going to find. They go find him.
They on the scene.
Read 4. See if you can set it up.
What are these?
Why? What is he like random off things?
I was gonna just put a screenshot of the note that JWoww wrote. Does anyone in here watch the Jersey Shore? No.
Okay.
Forget it. Read.
So you. Okay, so we're trying to find.
Don't forget to square root, guys.
Thanks, King. Thank you, King, bro.
So does it matter where in our diagram we put the 58.2 because we don't know which
You
side
should
of
put it below the mean because it's only 15% is like below it.
Okay,
You know.
maybe if I thought about that before.
Fine. You're good. Hey, I'm here. Although if I'm the extension of your brain, you're in trouble. Hold on. I gotta erase this. This is driving me nuts. Okay. Find the mean weight of the population. Have you guys been able to make your diagram yet? Are you guys good on making the diagram?
Yes.
Okay. Who can tell me if I have an unknown mean, what am I always going to write right under that? All right, let's set it up. Z equals X minus the mean over the standard deviation. How do you find the Z? Inverse norm of the area given from the left, however, in the standard normal distribution. Your mean is 0, your standard deviation is 1. The boundary associated with this is 58.2 minus the unknown mean all over the standard deviation, which was given. All right, go ahead, type it in. Find me the mean.
Where is your calc?
In front of me?
Where's what?
My
I feel
calculator.
like you haven't had a calc.
That's all right. I'm just get really lazy to pull this out.
I'm gonna say it is.
What'd you guys get? Negative 64.3?
Isn't it positive?
Yeah, I was just seeing if you guys were alive. Okay, 64.3, good job. And we don't have time to do one more. Okay, I'll be after for test corrections or spiral help if you need it.
Miss Falchuk, I have a quick question.
What's up?
Left her on red there.
The answer is no.
I don't know if you saw my email, but I want to change my IA. So do I have to
Oh, I saw your email. I was excited about it. Yeah.
Okay, do I have to redo task 2? I know I have to do task 3, but do I have to do task 2?
I think you should, if only to outline your idea so I know if it's gonna work or not. Also, instead of
All these
confidence intervals are from A2, so they're not gonna be enough math. So instead, what I would suggest you would do is,
other statistical analysis, I just don't know what.
you could find, you could do two things. So you could do the association between the cost, that you want to do cost of an education and your salary, right?
Yes.
Okay, so on your x-axis, you could have cost of the education. On the y-axis, you could have your final salary, and you could like see what kind of regression it is, calculate r squared or r, and compare that,
Yeah.
right? And then I would do a second analysis where it would be like, what were the other things you wanted to look at?
Like which professions like were like abnormally low return on investment or abnormally high, kind of, or I don't know, is that not what you're thinking?
Ooh. Yeah, that's what's up. All right. I'm trying to think of what your baseline would be though.
What do you mean?
You could just look up the salary that's like the most aligned with what would be like a perfect, what you examine your hoe. You would have to think of which, like, I don't know what I'm trying to say. I'm trying to say like what job, or no,
I was looking at
in terms of expected value, like what salary is the most closely linked to what you put into your education? Like what is the most like in for out, like a net, think of it like a net zero. Like if you pay a ton for your education and you get a crummy job, you would have like a big net negative. And if you had like, if you didn't pay a lot, but you ended up in like a high demand field where you make a lot of money, it would be like a net positive. So I'm trying to think of like, if you got a baseline and then looked at, oh my God. Okay. You're taking the bus, aren't you? Oh man. Hold on. Brennan needs me. Hold on.
I'm gonna go back.
I'll show you the picture.
All right. Hold on. Oh, what is it? Is it a fish? I
No,
love looking at a fish.
It's me and Addie, sorry.
Oh, you guys look so cute. I told, okay, my son loves Curious George. And I told him that you were the man in the yellow hat, and he was delighted.
It was, I wore it for like 10 minutes.
You guys look great. Oh, come on. Just come on. What are you doing? Let's try a different avenue.
What are you trying to do?
Print it for Brennan. Because you guys ate all the other spiral copies. Whoa, 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 whoa. What you doing? Oh my God.
Not saving my spiral till tonight.
Wait, how do you?
I'm almost done with it.
I'm so happy.
And I'm gonna stay after and I'm gonna finish it right now. And I'm
You're
not
learning.
gonna turn it in.
I approve of that.
Well, because my grade is at a 100, but it's almost down, so I have to do good on this one, so it doesn't break down.
Oh, okay.
Because I could do corrections and then
Come on. Like, what are you doing? Come on.
Alright, I think it's it. I'll be right back. I'm gonna print something
I
fast.
have to go too, so
Alright, I
I'm
think
not
it's
following,
it.
I'm not following you weirdly, I promise.
I just follow their shadow.
Alright, Matt, fools, what's up? Oh, what do you have in there so far?
Nothing. I wanted to change that thing, but I didn't know if it was like.
What are you gonna change it to? Hi, what's up? Are you haunting me? No. Oh.
I gotta go to the bathroom.
Okay. Did you see that basket? Yeah.